Now, solving equations with variables on both sides is a little bit more complicated, but not impossible. Again, we're still going to need our PEMDAS, our parenthesis, exponent, multiplication, division, addition, and subtraction on the right side in order to do this. Our entire goal, really, and we need to stay focused, is to get variables, I should say, on the same side. So we want the z to be on either the left or the right side. Now, one thing to look at is, since this 5z is on the right side and 4z is on the left, you might say, well, am I going to try and bring the 5 over to the left side, or am I going to bring the 4 to the right side? Generally, a good rule of thumb is to try and see if you can get the smaller variable, the 4z's over here, over to the right side. And we'll see why that's the case. But it would work either way, so you don't have to worry about making a mistake. The idea, though, is to just kind of know which one might make it easier for you. And some of that comes with experience. But the first thing we're going to do is we're going to try and isolate this 5z by itself. So because I have the subtraction here, the minus 1, what we're going to do is we're going to plus 1 on both sides. So we're going to take it here, like so. And we will do our algebra. We end up with 4z plus 5, because that's the addition that's coming down from here. And that's going to be equal to 5z. And since the minus 1 and plus 1 cancel out, we'd have nothing left over here. So now we're left with 4z plus 5 equals 5z. Now, since this is an addition, the opposite is going to be a subtraction. But I can subtract either one. I could subtract a 4z from this side and move it over here, or I could subtract a 5 on this side and move it over here. But if I subtract the 5 and move it over here, I still have my z's on both sides of the equal sign. So the idea is to see if we can avoid that. So let's see if we can move this z over to this side. Since this is a 4z plus 5, I'm going to subtract 4z completely from that side. Now you might say, well, this is a multiplication, why am I not getting rid of that? Well, I'm treating this as a full term by itself, so I can separate them. So this would be like if we, instead of having 4z, we said, well, this is really like an a, and this would be a plus 5. I could subtract the a from this side and move it over to that side. So that's what we're doing here. So here I'm going to subtract 4z from this side, and what you do to one side, you must do to the other side. So we end up with 4z over here, minus 4z, I should say. So this will cancel out, and we end up with 5 on the left side. And that's going to equal now a 5z minus 4z. Again, since they're the same variable number, I can literally just work with the coefficients here. So we have a 5 minus a 4 would basically give us 1, so this is 1z. And just simplifying this a little bit, we end up with 5 equals z. So the answer to this equation is z is equal to 5. Now we could check this quite easily by taking the 5 and plugging it into the z over here to see if this works. And this is a good idea to do. So if we do the check, we end up with 4 times 5, which we know is 20, plus 4 is equal to 24. Now if this works, we should get the same thing on the other side. And on the other side, we had 5 times 5 minus 1. So 25 minus 1 is also equal to 24. And so we end up with the two matching. So we're going to take a look at this example here where we have 4 times 5r minus 3 equals 2 times 4r plus 5. Now, the first thing that we should do is, since we see this number outside of the parenthesis, is we should definitely try and distribute them in. So we're going to multiply the 4 by each one of the terms. We're going to multiply the 2 by each one of the terms. And in this particular case, there might be a little bit an easier way to do it, but we want to go for the how to do this in terms of the sequence of steps. So the first thing we do is we distribute in. And we end up with 20 times r minus 12 equals, and I'll do my distribution here, so we get 8r plus 10. So now we have an equation that looks like the previous one. What we'll do is we're going to try and move the 12 over to the right side, so we'll basically add 12, because we like working with the addition there. What we do to one side, we must do to the other. When we do that, we end up with canceling this out. We end up with 20r on the left side, and we end up with 8r plus 22 on the right side. Now, we have this 8r plus 22. Again, we have an addition here between these two terms, so we're going to actually subtract 8r from this side. And what we do to one, we must do to the other. So we have 8r on this side. When we solve for this, we end up with 12r on the left side, and we end up with 22 on the right side. We're back to a single-step equation. We can divide this side by 12. What we do to one side, we do to the other side, this side by 12, and we end up with r is equal to 22 divided by 12. And we can divide both sides. To do it step by step, we can divide the top and bottom by 2. We end up with 11 over 6. And so the final answer is 11/6. R is equal to 11/6.